At its core, an optical mouse doesn't actually detect motion. It takes thousands of tiny photographs every second to track the microscopic textures of the surface beneath it. You can think of it as a specialized ultra high speed camera paired with a dedicated processor. An optical mouse relies on four main pieces of hardware to translate physical movement into digital cursor movement. The light emitter, usually a bright red light emitting diode or LED. Red is commonly used because the internal image sensors are highly sensitive to that specific wavelength, and red LEDs are highly power efficient. The optics, prisms and lenses. A piece of shaped plastic that angles the LED's light to strike the desk at a shallow angle. This highlights the microscopic peaks and valleys of the surface, creating tiny, distinct shadows. The CMOS sensor, a tiny, low-resolution camera. While it might only be 18 into 18 or 30 into 30 pixels in size, it is incredibly fast, capturing anywhere from 1500 to over 6000 frames per second. The digital signal processor DSP, the brain of the mouse. It is a highly specialized microchip dedicated entirely to analyzing the images captured by the CMOS sensor. When you slide the mouse across your desk, here is what happens in a fraction of a millisecond. Illumination. The LED shines its light through the prism, brightly illuminating a tiny patch of the surface beneath the mouse. Reflection. The light bounces off the microscopic textures, imperfections, and fibers of your mousepad or desk. Image capture. The focusing lens directs this reflected light into the CMOS sensor, which snaps a picture of the surface's unique shadow pattern. Pattern analysis. A fraction of a millisecond later, the sensor snaps another picture. The DSP compares the new image to the previous one. By identifying how the specific pattern of micro shadows has shifted, it calculates the exact direction and distance the mouse moved. Transmission. The processor translates this shift into X and Y coordinates and sends that data to a computer, causing the cursor on your screen to move accordingly. Why optical mice hate glass? Because an optical mouse relies on seeing shadows cast by microscopic surface textures, it struggles on perfectly smooth, transparent or highly reflective surfaces like clear glass or glossy magazines. The light simply passes through or scatters unpredictably, giving the CMOS sensor nothing to track, which causes the cursor to stutter or remain perfectly still.